Hi students, let's look at this question here, which was taken from the year 2018, paper 1 question 10 H2 math paper. You are given that an electrical circuit comprises of a power source V and a resistance R, a capacitance of C farads and inductance of L henries. Now the current in the circuit T after the turning on the power is I amps, and the charge of the capacitor Q capacitor is Q coulombs. Okay, the circuit can be used by scientists to investigate resonance, to model heavily damped motion, and to tune into radio stations on a stereo tuner. It is given that R, C, and L are constant. So these are pretty important things. R, C, and L are constants. So treat them as constants. All right. Then after which you have and that I, when I is 0, the current is 0 at time is 0. Okay, that's pretty okay. Now the first part is you're told to show under certain conditions where V, certain conditions on V, which will satisfy that equation there. So to show that, the first thing is you don't think too much, because you have a second derivative of second derivative of I with respect to t for what you are told to show. So you just differentiate with respect to t. Just get a second derivative and just think about it later. So differentiate with respect to t again. So use implicit differentiation for this part here. So we're gonna have now we are told that actually these three are constants, L, R, and C. These are constants, right? So if you differentiate this is okay. This is L. This would just be d square I, d square I, dt square plus R, di over dt. And because 1 over C is a constant, so this will be dq dt. That's pretty okay. And this will be dv dt. Okay? Now, once this is done, that's pretty. dq dt is given by I. We know that. So we could actually just replace this in since dq dt is equals to I. Okay, so this will be d square I dt square plus R di dt plus 1 over C I equals to dv dt. Okay, that's true. Now, so the question now is when would this be 0, right? So that's the question. So obviously, if this would be 0 when V is a constant, the voltage is held constant throughout the power source. Okay, so in other words, since dv dt is 0 when dv dt equals to 0 when voltage V is held constant. Okay, is constant throughout the circuit. The power source, the voltage is constant. So in other words, hence this will just be L equals d square I dt square plus R di dt plus I over C equals to 0. That's it. 2 marks. Okay, so I think the key point here is to state that the voltage is held constant, and also differentiate with respect to t to get the second derivative. So let's look at the subsequent part. You're told to show that C is equals to 4L over R squared. Given that I, so the second part is that I, which is a current, is given by E ATEIR over 2L times T. And A is a positive constant. A is a constant. Okay, A is a constant, right? So A is a positive constant. Now, this is important because when we differentiate it, we need to know which are constants and which are not. In the expression here, I would suggest that so basically we need to do a second derivative and just put it in. We know that RCL are constant, so just look at that. Okay, so what I'm going to do is actually just differentiate once and twice and just replace it in it, because this is a solution. this is a solution to this differential equation here. Okay, so the game plan is just to differentiate and just replace it because it's a solution, right? But before that, what I can see is that this will be very annoying because these are all constant. So we could just at the start just let k equals to negative r over 2l. It will be much easier if I let k equals to that constant over there. Okay, so this part here, what I'm going to do is actually just hence I would just be at e k t. So be very, very careful when you differentiate. So we need a first derivative and second derivative. Differentiate with respect to with respect to t. di dt will just be a product rule. So just slowly do it. This part here, what you get is u and this is v. Alright, so u, which is u dv dt. So this part here will be e kt times k plus e kt times 1. Okay, so this is done. So once we're done, we're just gonna factorize the e kt out, and this is kt plus 1. Just be very, very mindful of that expression there. Then second thing is I'm going to differentiate again, further differentiate this to second derivative because I just need to find these two expression and replace it in, right? So this part here, just be mindful, d square I dt square will be a, then do the same thing. What we're going to do is actually use this is u and this is v. Okay, so once this is done, what we can do is actually just use e kt dv dt, this is k, then plus v, which is actually kt plus 1, multiply with k e kt. Alright, so what we could do is actually just factorize out same thing. So this part here will be u, this is v prime. Be very mindful, okay, be very careful with your things that you're trying to. So what I'm going to do is factorize out the k and a, k, e, k, t, right? So this is 1 plus kt plus 1, which is actually a, k, e, k, t, kt plus 2. Alright, so there you go. Just slowly do it. Now once we have these two expression here, I'm going to just replace 2. Actually 1 should be here, and 3. Okay, because it's a solution, just sub into the equation there. So sub 1, 2, 3 into 4. Okay, I'm just going to try and solve this part here. L will just be a, k, e, k, t, kt plus 2. Okay, then this is 3, right? Then this is plus r. This part, this over here, r. So we're going to have r d I dt. di dt is a e kt plus 1. Okay, then I plus 1 over c a t e k t, okay, equals 0. That's about it. Now once we've done this, actually most of it is it's pretty okay once we are here. Before we sub it in, what I could just see that this common factor a, we could just divide throughout with this expression here. We're gonna get L k square t plus 2k. Maybe I shouldn't just skip steps, so just divide both sides with a e k t. Just cancel this up. Just like simplify this to k. Yeah, and this will just be r plus 1 over c t. If you're not too sure what's supposed to do, then what we're gonna do, just multiply this in plus 2k, 10 times L, just expand this, okay, 2k square TL plus 2k L plus r kt plus r plus 1 t over c equals to 0. So now is a good time to sub back your k in, which is negative r over 2l. So k equals to negative r over 2l. We just hope and see that it could be simplified, okay? So this will be r squared over 4l, cancel away. So I just do some mental calculation, not very difficult. So this this will be negative. So let me check first. K squared r squared over 2 4 squared l, cancel off 2k negative r negative r, right? K negative r and plus r negative r square over 2l. So this is negative r square over 2lt plus r plus t over c. Check your answers and see first what do we get. Okay, great. So I think this is okay. We managed to get this part. So this would be, this r would cancel away, thankfully. And this is 1/4 minus a half. So minus a half. So this is 1/4 minus half, which is negative 1/4. So okay, 1/4 minus half r square plus t over c. Is this t? Yeah, this is t here. The good thing about showing questions is you pretty much know that whether you got the answer correct or not. So this part here, once you get it, so hence negative r squared over 4l plus c, 1 over c has to be 0. And this would just be 1 over c equals to r squared over 4l. And c is equals to 4l over r squared. Yeah, it's tedious, but with the proper steps, you should be able to do this question here proficiently, okay? Let's look at the subsequent part 3. So part 3, you're told that for the subsequent circuit, you're told that r equals to 4, l equals to 3, and c equals to 0.75, right? It's okay. So just make sure that just check whether it satisfies this equation here. A quick check will tell that it satisfies this equation, so that's pretty okay. So in other words, you're looking at I equals to a te minus r over 2lt as the current, okay? Because if you satisfy this equation, meaning that this is actually the solution to the differential equation, you need to show that you need to find a maximum value of I in terms of a. Okay, great. So in other words, you want to find di dt at stationary value. Okay, di dt equals to 0. So in other words, di dt equals to 0 would just mean that this equals to 0. So aekt, and after which we have kt plus 1 equals to 0. Now the thing is, this cannot. So this cannot be 0. This is more than 0. We know that this is always more than 0. So in other words, you're looking at kt plus 1 equals to 0. So t equals to minus 1 over k. In this case here, the time at which it will be a stationary value is minus 1 over k. So just bring out your k, which is actually negative r over 2l. So this is negative r over 2l, and this is just 2l over r, which is okay, which is not too bad. So it's 2 times 3 over 4, which is actually 3 over 2. Okay, time is in seconds. Okay, there you go. So this is the part which they want you to find the t. Once you found the t, you could actually find the I, the value here, I, which is actually a 3 over 2 e. K is actually just, this is negative r 4 over 2 times 3. Then t will just be 3 over 2. This is A, 3 over 2E, 3, 3, 4, negative 1. Oh, so this is 3A over 2E. Okay, this is the current which will be, they need you to show its maximum. Showing its maximum, you just substitute into the second derivative here, which we have here. So d square I dt square from 2, we know that this will be A ke kt. This will just be kt plus 2. So we substitute the timing in. K is positive, right? Is K positive? K R positive. K is negative. K is negative R over 2L. We negative 4 over 2 times 3, which is actually negative 2 third. Okay, so what we can do is A negative 2 third, E negative 2 third is 3 over 2. K is negative 2 third. This is 3 over 2 plus 2. Okay, A is positive constant. So what essentially, this is also positive. So this is A negative 2 third. Key in calculator, this would just be this is 3, 1. So this is 1. Oh, this is negative. So this is negative since AE is positive. Okay, so this is negative, hence I is maximum. There you go. So this is how you do this question here proficiently. So for the last part, we are told to actually sketch the curve, the graph of I. I think that is pretty okay. IV, so it will be I equals to ATE R2L, so that is my K, which is negative 2 third. Right, K, which is negative 2 third. K, yeah, this is the graph here. So just bring out a GC, and we're just going to sketch this graph here. I think this graph is pretty okay. A is a positive constant, so it doesn't really matter what we sketch, right? So we're just going to find out by just plotting in the graph. So TE, so this is A, X e to the power of negative 2 third X. This will just be graph. Okay, so this is the graph here, but obviously we need it to be positive, the positive curve here. So you could just put X bigger than 0 and just graph it. Okay, but if you want it to be like bigger, you could just put a bigger value. But what I could do is zoom windows. I'm just gonna put Y max as 1 so that it looks nicer, and Y min as maybe negative 0.1. Yeah, okay, so this is the graph that we're looking at. We are just going to sketch it. So this part starts off with this is I, this is A, and you just draw it like that. This is 0, 0, because it starts with 0, right? And this part here, it's a maximum point. So this point here will be negative, T will just be 3 over 2. This is 1.5 seconds. Okay. This is I against T. Then this will just be 3 over 2A over E. Okay, so this is, you can just put it as such. Maybe. Yeah, so this is how you do this question here proficiently. Any question, comments, please do let us know. Keep practicing, and I'll see you in the next question.